400 million miles from Earth, a tiny moon is tearing itself apart. Its name is Io, and NASA has been watching it for decades. Io orbits Jupiter, the largest planet in our solar system. It's roughly the same size as our own moon.
But nothing about it feels familiar once you look closer.
Io is the most volcanically active object in the entire solar system. It's covered with roughly 400 active volcanoes. That's more volcanoes than any planet or moon we've ever studied. And they never really stop erupting. So why is this small, rocky moon so violently alive? The answer lies in a brutal cosmic tug-of-war. Io circles Jupiter once every 42.5 hours. That's an incredibly fast, tight orbit for a moon its size. As it swings around, Jupiter's gravity grabs and releases it. Two nearby moons, Europa and Ganymede, pull on it too. Together, their gravity stretches and squeezes Io from every direction. Scientists call this relentless squeezing tidal flexing. Io's surface actually bulges up and down by about 330 feet. Imagine the ground beneath your feet rising a football field's length. That's the kind of stress Io endures every single orbit. All that flexing generates enormous amounts of internal friction. And friction, over time, turns into heat. That heat melts portions of Io's interior into molten rock. The result is a moon with lava constantly seeking a way out. For over 40 years, scientists had one big unanswered question. Was Io hiding an entire ocean of molten magma underneath? Or was something else powering all those separate volcanoes? NASA's Juno spacecraft was about to find out. Juno arrived at Jupiter back in 2016.
Its main mission was studying the giant planet's atmosphere and interior.
But after years of orbiting, NASA extended its mission further. That extension let Juno start swinging close to Jupiter's moons. In December 2023, Juno made an extremely close pass of Io. It flew within about 930 miles of the moon's tortured surface. Then it did it again in February of 2024. Each flyby gave scientists an unprecedented, close-up look at Io. Juno carried a special instrument called JIRAM for this work. JIRAM detects infrared light, the kind of heat our eyes can't see. It was originally built to study Jupiter's deep, swirling clouds. But it turned out to be perfect for reading Io's volcanic heat. During those close flybys, Juno tracked tiny shifts in its own speed. Those shifts revealed subtle changes in Io's gravity field. Gravity data can tell you what's hiding beneath a surface. If there were a global ocean of magma, gravity would show it. The Juno team ran the numbers again and again. And the data told a surprising story. There was no giant hidden ocean of magma inside Io. Instead, scientists found something more like separate underground furnaces. Each volcano seemed to have its own private chamber of hot magma. It was less like one lake of fire, more like hundreds of forges. This finally solved a mystery that had puzzled scientists for decades. The discovery answered a question dating back 44 years. Researchers published the findings in the journal Nature in December 2024. But Juno wasn't finished making discoveries on Io.
On December 27th, 2024, Juno flew past Io one more time.
This flyby was farther away, about 46,000 miles out. Still, Giram's infrared eye caught something extraordinary. It detected a hotspot so bright it overwhelmed the instrument's sensor.
Scientists had never seen a signal that intense from Io before.
At first, it looked like one single, massive eruption. But closer analysis revealed something even stranger. It wasn't just one volcano erupting at all.
Multiple volcanic sources had ignited at nearly the exact same moment.
Their brightness spiked over 1,000 times above normal levels. That kind of synchronized eruption doesn't happen by accident. It suggested a vast network of connected magma chambers underground. Somehow, molten rock was moving through the moon in unison. The eruption stretched across roughly 40,000 square miles of surface. That's an area larger than the entire state of Kentucky. The affected region alone was bigger than Lake Superior. And Lake Superior is the largest freshwater lake on Earth. The energy released was almost impossible to comprehend.
It put out 6 times the energy of every power plant on Earth combined.
Every factory, every dam, every reactor, multiplied by 6. Total power output topped 80 trillion watts.
Scientists called it the most powerful eruption ever recorded on Io.
In fact, it may be the strongest volcanic event ever seen in the solar system.
Even the eruption's own discoverers were stunned by the numbers.
Juno's principal investigator said the data simply blew their minds.
This eruption even outshined Io's most famous volcanic feature.
That title had belonged to Loki Patera, a massive lava lake. Loki Patera alone covers about 7,700 square miles.
This new hotspot simply dwarfed it in scale and power.
Juno's other camera, JunoCam, backed up the discovery visually. Scientists compared images taken months apart around the same region. The surface coloring around the hotspot had visibly changed. That kind of shift is a telltale sign of fresh eruptions. Io doesn't just erupt lava either. Its volcanoes also blast plumes of ash and sulfur gas skyward.
Some of Io's plumes have reached over 200 miles high. That's not a typo, 200 miles above the surface.
That sulfur is part of why Io looks so strange. Its surface glows in shades of yellow, orange, red, and black.
Scientists often describe it as looking like a cosmic pizza.
It's a nickname that's oddly fitting and hard to forget.
Juno plans to keep flying past Io in the years ahead.
Each pass adds another piece to this fiery puzzle. Io reminds us, our solar system is still wildly active. Somewhere out there, real fireworks are erupting right now.
And thanks to NASA, we're finally watching them up close.